Pearson's product moment and least squares regression. Here, we are going to measure the correlation between hours of study, represented by the letter H, and score, represented by the letter S, via a tool or method called Pearson's product moment. Then proceed to calculate the slope and the y-intercept of a line of best fit. So here are the data values. The x variable, the independent variable will be hours, and the dependent variable or the response variable will be score. Here are the formulas, and as you can see, sigma is present in practically everywhere in these formulas. So here we outline the modified version of the orders of mathematical operation. B for brackets, whatever in the bracket, you have to do it first. E for exponent, you'll do that after. Multiply and division comes interchangeably after exponents, after exponentiation. And subtract and sum. So we're using S for subtract and we're using sigma for sum. That's the modification that we did here. And they both will come last interchangeably. So we put sigma for last to stress the fact that in these formulas, you always begin by doing what is to the right of sigma first, and you reserve sigma for last. Always sum last. So here's the formula for Pearson's product correlation. You've got to calculate 6 numbers, and here you have the simplified version of it, A, B, C, 3 numbers, and A is equal to the first minus the second, B is equal to the third minus the fourth, and C is equal to the fifth minus the sixth. And here's the formula for gradient or slope, represented by the letter M, and as you can see, it is very similar to the product moment correlation formula. Actually, the numerator is exactly A, and the denominator is exactly B. So really and truly, we can simplify M to be equal to A over B. And see now the y-intercept is the sum of y minus M, which I've calculated, which would have been calculated already, times the sum of x, which of course also would have been calculated already, divided by n. N here is 1, 2, 3, 4, 5, 6, 7, the number of pairs, and that will give us the gradient and the y-intercept of the line of best fit. So as you can see, we have inputted our data values in Excel. So we are first going to calculate the coefficient correlation, Pearson's product moment. First, we have to find xy before to find the sum of xy. So to find xy, we go to where the column of xy is, we type equal, and then we type our first x is in A2, we type this times. Our first y is in B2, we type, and then we type enter. And to find the other xy's, we double click on this green square in the lower right corner and we drag. And then these are all our xy's. And to find the sum of xy's, we go to editing and we type, click on auto sum and we type enter. And this will give us our sum of xy. And to find n times the sum of xy, remember n is 7, we type equal, n of sum, n times the sum of xy is equal to 7 times the sum of xy, which is in C9, and we type enter. Now we need to find the sum of x and the sum of y. So to find the sum of x, we go to A9 and we go to auto sum. We are going to sum the x's. And here Excel has highlighted them. The sum of x is equal to 158. And we can simply drag this formula to find the sum of y. And now we can easily calculate the sum of x times the sum of y is equal to A9 times B9. Enter. Now we need to find n times the sum of x squared. So we need this x squared first to find the sum thereof. So we go to the column labeled x squared and we type equal, and our first x is in A2. We click on 2 and then we type raised to the power of 2. And that's our first x squared. To find the rest of the x squareds, we go to the green square, we double click and we drag. That's all our x squareds. And to find the sum thereof, we click on D9, we go to editing, auto sum, and we find the sum of x squareds. Now to find n times the sum of x squared is equal to 7 times D9. That's where the sum of x squareds are. and we type enter, and this will give us n times the sum of x squared. Now we want to find sum of x all squared. So the sum of x all squared is equal to, now we go to where to find the sum of x, which is in A9. We click on A9, and then we raise this to the power of 2. This will give us the sum of x all squared. So as seen, I did not raise A9 to the power of 2. So let's go there. Raised to the power of 2, and then this will give us the sum of x all squared. Now, n times the sum of y squared. We need y squares to find the sum. So we go to the column label y squared. We type and we click on the first y, which is in B2, and then we raise this to the power of 2, and this will give us the first y squared. To find the rest of the y squares, we double click on this green square and we drag and we go down, and this will give us all our y squares. Now to find the sum thereof, we go to editing, auto sum, and here we have all the y squares, and n times the sum of y squared is equal to 7 times, and we click on E9, and this will give us n times the sum of y squared. Now the sum of y is all squared. So we type equal, and we go to where the sum of y is, which is in B9, and then we raise B9 to the power of 2, and we type enter. This will give us the sum of y all squared. Now we know that is equal to the first, a is equal to the first number, which is in Bn, minus the second number, which is in B11. B is equal to the third number, which is in B12, minus the fourth number, which is in B13. C is equal to the fifth number, which is in B14, subtract the sixth number, which is in B16. And the correlation now is equal to A divided by the square root of B, which is in D11, times C, which is in D12, close bracket, and this will give us a value of R. To verify this value of R, we go to formulas, we go to insert function, we go to statistical, and then we go down to Pearson's. Here it is. Okay. The first array of numbers are the explanatory variables, which is in A2 to A8. The second array of numbers is in the column B. That's the response variable from B2 to B8. And here it is. Excel has proven to us that this is the actual value of R. Now we need to find M. As you can see, M has been simplified to A over B. Okay, so that the slope is equal to A is in B10 divided by B, which is in B11. So this is our slope, 1.2, and our y-intercept is equal to the sum of y. We can use a bracket. The sum of y, as you can see, the sum of y, which is in B9, click, minus M, which is in F10, times the sum of x, which is in A9, close bracket, divided by n, which is 7, and we type enter, and our slope is 1.2, and our y-intercept is 34.77. And this can be verified by simply going to, that's one of the ways. You can go to data, and you can go to data analysis. If your Excel does not have data analysis, then you can add it in. You go to regression. We're on regression already. Click OK. And our first set of our input, that's our y variables, are from B2 to B9. Here it is, B2 to B9. And our x variables, which are the independent variables, from A2 to A9. As you can see, the y variables appearing first, and just click OK. And as you can see, here it is. Our slope is 1.2, and our y-intercept is 44.76. just like we calculated here. 769, so it's 0.77. And another way to verify the slope and the y-intercept is by actually highlighting the x and the y variables. You go to Insert, and we are going to create a scatter plot. You go to Charts, Scatter, and here you have a scatter plot. Then you go to Quick Layout, and you choose the function, the one that has the function in it, and here it is. The y-intercept is 44.77, and the slope is 1.2, as you can see, and the coefficient of determination is 0.96. 1.2 and 44.77. So this is the equation of the line of best fit.